friends. Today we will be discussing the locus of a point. Yesterday we had distance formula, and today we are dealing with how to find the locus of a point which is satisfying the given conditions. Let us work out certain examples. What do we mean by the locus of a point? It is an equation found by satisfying the given conditions, in the sum. Now let us see the same by examples. Like, let us find one example. A moving point. A point is moving. A moving point P moves such that, now here are certain conditions. A point is moving and it moves in such a way that its distance from A square, its distance from B square, and the sum of the same remains 25 forever. A moving point P moves such that it satisfies the given condition where the coordinates of A 2, 3 and that of B is 4, 5. A has 2, 3, B has 4, 5. Find the locus of that moving point P. Okay, so let us collect what we are given. Here A has coordinates 2, 3. That of B is 4, 5. And which condition is given to us? The condition is that PA square plus PB square remains 25. P is a moving point. Let us assume, let PXY be the moving point. Suppose P is a moving point and its coordinates are X and Y. Let be the moving point. Let us substitute the values in the given condition. Distance of P from A square. So we have x minus 2 square plus y minus 3 square plus, let us find pb square, x minus 4 square plus y minus 5 square remains 5. Now let us simplify. Let us open up. It is x square minus 4x plus 4 y square minus 6y plus 9 plus x square minus 8x plus 16 plus y square minus 10y plus 25 is equal to 25. Let us simplify the expression and see what we are getting. On simplification, we find that x square plus x square is 2x square, y square plus y square 2y square, minus 4x minus 8x result in minus 12x, minus 6y minus 10 has 16, 25 cut, and the resulting constant is 25 equal to 0. So the coordinates of that moving point P, that is x and y, satisfy this equation. So that is the required equation. We say that which is required locus of that moving point. Locus is nothing but the path traced by the moving point satisfying the given condition. So that was the required one. Let us see different cases and find the locus. For example, find the locus of a moving point P such that this point moves such that its distance from the points A 5, 7 and B 2, 3 remains same. Now this is what we are given. We want to find the equation, that is the locus of a moving point P, such that its distance from A and its distance from B remains same, that is equal. So here we have A as 5, 7. The coordinates of B 2, 3. Suppose let PXY be the moving point, that is, we are assuming the coordinates of the moving point as X and Y. The condition, the mathematical form of the condition given to us is its distance from A and B remains same, that is, distance of P from A is equal to its distance from B. We know the distance formula. On squaring, we find that PA square is equal to PB square. A has 5, 7, B has 2, 3. So, PA square is found to be X minus 5 square plus Y minus 7 square is equal to X minus 2 square plus Y minus 3 square. So this is what we are getting. We simplify it further and find that x square minus 10x plus 25 plus y square minus 14y plus 49 square of 7, that is equal to x square minus 4x plus 4 plus y square minus 6y plus 9. So this is what we are getting. X square cut y square minus 4x minus 10x. On simplification, I find that it is minus 6x minus 14y minus 6 give us minus 8y, 25 plus 49 is 74. On the other hand, I find 9 plus 4, 13. So finally, it is minus 6x minus 8y, 74 minus 13 is 61 equal to 0. Let us multiply the equation by minus 1 and we find that 61 is equal to 0. So the coordinates of the moving point P, x and y satisfy this equation, and that is our required locus, which is required equation or locus. Here actually there were two different points, A and B. A and B. A point P moves in such a way that its distance from A remains same as its distance from B. So the midpoint of the line segment AB was P. So if I take a perpendicular bisector, રેખાખંડ AB ને લંબ અને એના મધ્યબિંદુમાંથી પસાર થતી આ જે આપણે રેખા લઈએ, that is called perpendicular bisector. સમ લંબ દ્વિભાજક એનું આપણને સમીકરણ મળે છે. So what we are getting, which is this equation, is equation of this perpendicular bisector. So that is found to be 6x plus 8y minus 61 is equal to 0. So according to the given condition, we are supposed to substitute the values, simplify, and whatever equation we find in terms of x and y will be our required equation. So that was one good example of perpendicular bisector. Let us proceed ahead and find few more. Say a point P moves in such a way that, so will be given a condition. A point P moves in such a way that its distance from the fixed point A12 remains thrice its distance from its distance from A12 remains 3 times its distance from B45. So that is what we are given. We are to find the equation, the locus, the path traced by that moving point. Find locus of that moving point P. So we say that what we are given, A has 1, 2, the coordinates of B 4, 5. As usual, let PXY be the moving point, its coordinates X and Y, be the moving point. The important part is the condition in mathematical form. Distance of P from A, that is PA, remains 3 times its distance from B45. અર્થાત Pનું Aથી અંતર એ તેના Bથી અંતર કરતાં 3 ગણું છે. The mathematical condition becomes like this. It is 3 times PB. Let us square both the sides and we find that PA square is nothing but 9 times PB square. Okay. And let us substitute the values using distance formula. It is x minus 1 whole square plus y minus 2 whole square equal to 9 times. It is PB square x minus 4 square plus y minus 5 square. So this is what we are having. Let us further simplify the expression. It is x square minus 2x plus 1 plus y square minus 4y plus 4 is equal to 9 times x square minus 8x plus 16 plus y square minus 10y plus 25. So on simplification, we have reached up to here. Let us simplify it further, and we find that it is x square, the left hand side, y square is there, minus 2x minus 4y, 4 plus 1 is equal to 5. The right hand side, I find that 9x square minus 72x 16 into 9. 16 into 9. Let us carry out the multiplication. It is found to be 144 plus it is 9y square minus 90y plus it is 25 into 9. We carry out the multiplication and it is found as 225. Let us simplify it further. 9x square, 1x square on the right hand side, I will be left with 8x square, y square and 9y square give us 8y square. There is minus 72 plus 2 give me 70x, minus 90 plus 4 give us minus 86y, 225, 144 and that is 5. So on simplification, 225 minus 5 is 220, 220 plus 144. Let us carry out the sum somewhere. It is 463. It is 364. So 364 is equal to 0. So this is what we get. On looking at the equation, I find that it is divisible by 2, say. Let us divide the equation by 2 and we find that 4x square, 4y square minus 35x minus, we are dividing 86 by 2 and we get 43 plus 364 divided by 2 give us 182, that is equal to 0. So this is the equation which is satisfied by the coordinates of the moving point P. This is the equation. So we say that it is required locus, which is required equation or locus of that moving point P. So in this way we are supposed to solve the equations. Using distance formula we can solve the given sum. Further, let us find one more example. A point P is moving. P moves in such a way that point is moving, that the ratio of its distances the ratio of its distances from the fixed points A has coordinates 3, 4 and B -4 -3. Those are the coordinates of B, and the ratio always remain 3:5. એક ચલિત બિંદુ P એવી રીતે ગતિ કરે છે કે તેના A તથા B બિંદુઓથી અંતરોનો ગુણોત્તર હંમેશા 3:5 રહે છે. તો આ ચલિત બિંદુનો બિંદુપથ શોધો. Find the locus of this moving point P. So we proceed and find the following. As usual, let coordinates of the moving point P be xy, pxy is moving point, we are given two fixed points. A has 3, 4. The coordinates of B -4 -3 and the mathematical form of the given condition. The ratio of the distances that is PA to PB is given to us as 3 divided by 5. On simplification, I find that 5 times PA must equal to 3 times PB. As we know that we are to use the distance formula, let us square both the sides, and I find that 25 PA square must equal to 9 times PB square. So this is what we have. The coordinates of A, coordinates of B, we substitute and we find that 25 PA x minus 3 square plus y minus 4 square, y minus 4 square is equal to 9 times PB square. It is x plus 4 square plus y plus 3 whole square, like this. So this is what we are getting. Let us simplify it further, and we find that 25 into it is x square minus 6x plus 9 y square minus 8y plus 16 it is. That is equal to the right hand side is x square plus 8x plus 16 plus y square 6y plus 9. So on simplification, we find that it is 25x square, 25 into 6 is 150x, 25 into 9 it is 225 plus 25 y square minus 200 y plus 25 into 16, 16 5s are 80, 32 plus 8, so the multiplication comes out to be 400 on the right hand side. It is 9x square plus 72x plus 9 into 16, 144, 9y square, it is 54y plus 81. So, on simplification, 25x square minus 9 comes out to be 16. First, the term containing x square. Next, let us collect the term containing y square. It is also 16y square minus 150x minus 72 comes out to be 222 x 200y minus and 54 minus is 254y. Okay. Plus the constant, it is 225 plus 400 is 625 and 144 plus 81 is 225 on that side minus, so that is equal to 0. So I find that 16x square plus 16y square minus 222 222 254y plus 400 is equal to 0. Let us check any number is common or the equation is divisible by any number. Let us first divide it by 2. Divide the equation by 2 and we find that it is 8x square plus 8y square minus 111 minus, it is 254 divided by 2, we find 127 plus 400 by 2 is 200. So this is the equation we were in search of. That is, the coordinates of the moving point satisfies this equation. So we say that is required equation. Required equation or locus of that moving point. So this way we can solve the equations. Let us have just one more. If P is a moving point, P is a moving point, it satisfying the condition given to us is as under. It is satisfying PA square plus PB square is equal to 50. The sum of the squares of its distances from A and B remains 50 constant, where the coordinates of A 1, 2 and that of B is 2, 1. Then find the locus of the moving point P. So let us see what we are given here. The fixed points are A has 1, 2, that of B, A na yam 1, 2, B na 2, 1. Let PXY be the moving point. As usual, the mathematical form of the given condition, it is given that PA square plus PB square is 50. Let us substitute the values and we find that x minus 1 square, y minus 2 square plus x minus 2 square, y minus 1 square is 50. And we simplify it and find that x square minus 2x plus 1 plus y square minus 4y plus 4 plus x square minus 4x plus 4 plus y square minus 2y plus 1 50. X square plus x square 2y square minus 2x minus 4x minus 6 minus 6y it is. And now we collect the constant. It is 1 plus 4, 5 plus 5 is a 10 and 50 on that side is equal to 0. So finally we come to 2y square minus 6x minus 6y minus 40 equal to 0. On dividing the equation by 2, we find the resulting equation as x square plus y square minus 3x minus 3y minus 20 equal to 0. So, the locus of the moving point P satisfying this equation is found as this one. So we say that it is required locus. That is the required one. So using the concept of locus, using the distance formula and the concept of locus, we will be solving the sums and getting the equation. Thank you.